This video is looking at the different types of testing. You could start by looking at one of the types of error that you can get when you're doing your testing. First of all, we look at syntax error. A syntax error is when the compiler or interpreter doesn't understand something you've typed due to not following the rules of that language. So in other words, when you run your program, it comes up and tells you that you've done some sort of error, and it does that because it looks at all of the different available language and commands and punctuation and everything that's supposed to be for that language, and anything that it finds that isn't normal comes up as a syntax error. For example, with this Python program, when you try to run the program, just a simple one line of code, print coding for beginners in easy steps, it comes up with this syntax error box. EOL while scanning string literal. Now it highlights inside the IDE with a red bar at the end. So inside this development environment, you can see a big red bar, and it kind of gives you a clue as to where the actual mistake is. Now there's actually only one mistake here, and that is that you haven't said when to end the string. So this particular string coding for beginners, it starts with the first apostrophe, but it hasn't ended. So you know that that's what's missing at the end of that line. Another example of logic error syntax is when the compiler or interpreter is able to run the program, print, but it does something that is unexpected, and it indents. So in other words, the whole compilation process. Now anyone that's coded in Python is going to know that the program will run if statement or an else, but then when you're trying to do it and you're running the program like you want it to work, the different loops like what you want it to do. While loop, we need to have the next line of code indented. So if we indent first example of a logic error here, then that error you're looking at the program, and it will then come up with another error. Prints thank this God. One's basically asking you to put in your scores for throwing new darts. It will then run the program. So if you throw your first dart and you get, I don't know, like a 13, then you throw it again and you get 2, you throw it again and you get the bullseye. Now you put the scores in for those darts, and what this is doing is calculating the total. So on line 4, it's calculated the total score for your 3 darts, and then it does a bit of selection. So if the total is greater than 140, it's going to print Mr. Rooney is the best at darts. If you get a total that's less than 180, less than equal 180, it's going to say 180. Otherwise, it's going to say Mr. Rooney is rubbish. So basically, if you get a score above 140, it's saying you're good. If you get less than 180, it's saying 180. And if you get anything else, it's saying you're rubbish. So we can see that the logic error is that it says less than 180. We want it to be equal to. So what it should be there is 2 equal signs. So that program would have run, but it wouldn't have done what you wanted it to do. This program actually has a syntax error as well, because you can't just put if. It should be if, elif, because it's all different conditions relating to the same program. Once that's completed, if you look at it and it runs, but doesn't do what you'd expect it to do. So if you get 70 marks, what's happening is it's checking to see if you've got greater than or equal to 70 to give you a grade A. But it's also checking to see if you got less than or equal to 70 for a B. So one of those things need to change. I personally would make the grade B less than or equal to 69. And that way 70 or above will get you a grade A. So when we're looking at error information, it's a lot more difficult to spot a logic error. As you can see, the program will generally run, but the difference is with a logic error, you can't always see it. You can't always see where the problem is, and it takes a little bit longer. The program will still run because all the syntax is right, but it doesn't do what you want it to do. Syntax errors are usually identified by the compiler itself, and it often tells you where the error is, such as a line number, or highlights it in a certain color. The program won't run if there's a syntax error, so it makes it much easier to find. Best way of stopping errors in your program is to test your program properly. So let's look at the different types of testing. First one's functionality testing. So this is essential for finding any logic errors. Once the program's compiled and it works, you need to functionality test the program to make sure it does what you expect it to do. This would normally be done alongside the development process, so you'd kind of do it as you went along, so that you didn't get to the end and realize that you've done everything in kind of the wrong order. You can also have performance testing. So this is where you see how quickly certain features run. So for example, you open up PowerPoint, insert a chart, and you want to see how fast it takes to insert a chart. Usability test. This is where you see how user-friendly the interface is. So you would test it on some users and see how easy they found to run the program. Security tests are when we look at it and see how vulnerable the program is, to see whether anybody can gain access to bits that they're not supposed to. Finally, the load and stress test. So this is to see how the program runs while different users are using it at the same time. So final testing is the program only goes through the development cycle once. So you literally sit and do your whole program all the way through, and you don't test it until the end. A test is completed when everything is finished for all of the user requirements. If it meets their requirements, then the thing gets signed off. So the obvious advantage of doing this is you don't need any real kind of collaboration with the audience or with the users. You just do everything yourself and test it at the end. The disadvantage of this is obviously if something doesn't work and you've done something wrong in the development, you might have to go right back to the start and do it all over again. Iterative testing is when you go through the development cycle a few times, so you keep testing continually. This will ensure that the program is exactly what the customer wants. You can also make extra additions during this time, so you can go through, and as you're doing the testing, you realize that they actually wanted to do something extra, so you put an extra addition in as you go. The obvious advantage to this is that the customer gets exactly what they want. The disadvantage is that obviously you need a lot more collaboration, a lot more meetings with the users. One method that you can use when developing a program is to create a test plan. Think about what the actual user wants from the program and create a plan that will basically say, what am I going to test as I'm going through? This allows you to then test the program during development, and it'll also help you to test any potential issues that arise at the end of the process. Here's an example of a test plan. So basically what you could do is list all of the tests in the left-hand column. Then you could give it a sensible title, summarize what it exactly is that you're testing, say what steps you're going to take to make that test, give some sort of test data, so what are you going to input, what would you expect it to do, what actually happened, and then from that you can then say whether it's passed or failed. When you are sticking things into your test plan, you have to think about what data you could stick in. So say for example you were testing a date of birth box or some sort of like age calculator. You need to put in some example data. So you would test normal data to see whether it does what it's expected to do with normal data. You would stick some incorrect data in, so maybe something that isn't even numbers. And you would stick some extreme data in, so something where maybe someone's 150 years old and you think, should that be possible or is that a little bit extreme? That's the end of the video about testing. Our next video is about IDEs.